Today we're going to be sketching cubic graphs in the form of y equals a bracket x minus h cubed plus k. And what we're going to be doing is looking at how it transforms around the Cartesian plane from the original y equals x cubed. So if I look at what the basic graph of y equals x cubed looks like, you'll notice that from negative infinity to positive infinity along the x-axis or its domain, you'll notice that it covers every single value. Its range also covers every single value from negative infinity to positive infinity because it goes like that. You'll also notice there's a special point here going through the origin. We call that the point of inflection. And this here is our value of hk. So hk in our basic y equals x cubed is 0, 0. When we transform this cubic graph around the Cartesian plane, the point of inflection moves depending on what h is and what k is. A is our dilation factor, which obviously tells us whether this is going to be stretched in one direction. If a is negative, we know it's being also reflected in the x-axis. And so a negative x cubed graph looks like this. Continuing again on to negative infinity and positive infinity, like so. So let's have a look at what changes have occurred within this equation. So if I write x minus 2 cubed plus 3, what we can say is that the point of inflection has moved 2 places in the positive direction and 3 places up in the positive direction. And there's been a dilation factor of 2. It's still a positive x cubed, so it will still go in this direction. It's just the point of inflection will have gone 2 along, 3 up. That means that there's going to be a different x-intercept. And we will need to establish what that x-intercept is, and likewise the y-intercept. Today is going to be all about sketching. So when we sketch any graph, we need to include the x-intercepts, y-intercept, and then any point of inflection, the coordinate of the point of inflection. I'm going to clear the board and then we'll have a look at how we sketch one. The graph of y equals x minus 2 cubed plus 4. So what we notice here is there's been a horizontal shift of 2 places in that direction and a vertical shift of 4 up in that direction. Also, the value of a is positive. It's a 1, but it's positive, so we're dealing with a positive x cubed graph going in that direction. So it's a really good idea to know whether it's positive or whether it's negative. So we need to find the y-intercept, and of course that occurs when x equals 0. So if I substitute in when x equals 0 into here, I get 0 minus 2 is minus 2, minus 2 all cubed is 8, minus 8, plus the 4 gives me 4. So the y-intercept is 4. I better substitute that in there. So y-intercept is 4. So we're going to have a y-intercept of 0, 4. Now let's have a look at the value of hk first, our turning point, not our turning point, apologies, the point of inflection. So the point of inflection is 2, 4. And the last thing we need is our x-intercept. So what we've got to do is solve for when y equals 0. So x-intercept when y equals 0. So we go 0 equals x minus 2 cubed plus 4. Well, this is a straightforward one to solve because I can subtract 4 from both sides and I can cube root negative 4. So when I cube root negative 4, I'm left with, I'm left with x minus 2 and then the cube root of negative 4. Then x equals the cube root of negative 4 plus 2. So when I sketch it, I know it's going to look like this. My hk has moved here and up here, so it's going to look like this. My y-intercept is at 4. So, oh, hang on, minus 8 plus 4, negative 4. Apologies for that. I do make mistakes sometimes. So my y-intercept's down here. So therefore my x-intercept's somewhere here. So the sketch is going to look something like this, where my point of inflection is here at 2, 4. Don't forget your arrows going off in both directions. There's my -4, and this point here is the cube root of -4 plus 2. All right, and that's the first sketch. What I'm now going to do is do a sketch where the coefficient of the x is not 1. In order for our value of hk to show, we need to have a coefficient of x. So anything where the coefficient of x has to be +1. Any coefficient that is in front of the x that isn't a +1 we'll need to pull out as a factor. So I'm now going to sketch this graph here. And what we do see is we can't tell what the dilation factor is, and we can't tell what the horizontal shift is because the coefficient of x isn't 1. So first thing we need to do is pull out this factor of 2, which will affect these two values here. But it's not 2 we're pulling out, it's 2 cubed that we are actually pulling out. So let's do that first. I'm pulling out the 2 as though it's 2, but it's 2 cubed, leaving with x divided by 2 is +2 cubed minus 3. Now we can work this out. So a half of 8, because 2 cubed is 8, is 4. Multiply by x plus 2 all cubed minus 3. Now this is in the form of y equals a bracket h minus x minus h all cubed minus 3. So we can see that the point of inflection is now at -2 minus 3, and the dilation factor is 4, which is a positive number, so we're dealing with this kind of direction for our cubic. So we still need to find any x-intercepts, y-intercepts, etc. So let's do the x-intercepts first, and they occur when y equals 0. So when y equals 0, we get 0 equals 4 bracket x plus 2 cubed minus 3. Move the 3 over and divide by 4 equals x plus 2 cubed. I can cube root this, cube root of 3/4, whatever that is. I'll probably estimate that or use a calculator. And then to find x, I'm going to subtract 2. So x becomes the cube root of 3/4, take away 2. Let's find the y-intercept now. The y-intercept occurs when x equals 0. So doing that then, subbing 0 into this one, apologies, there we go. Y equals 4 multiplied by 0 plus 2 cubed minus 3. This becomes 2 cubed, which is 8. 8 multiplied by 4 is 32. Take away the 3. Our y-intercept is going to be 29, positive number. So it's quite high up here because our hk is -2 minus 3. So our hk is down here. So hk is -2 minus 3. All right, so when we sketch this, I'm going to probably clear this space, sketch it right here. It's going to have a kind of positive go like that, but it's going to be quite high up. So probably, oh, that's very off scale because that would be 29. It's quite, we don't know what the scale is, it's just a sketch. Down here is -2 minus 3, and the x-intercept here is a negative value because it's take away 2. So we pop on there. Difficult because my sketch was a bit poor. I'd probably scrap that and do it again, but for this video I don't need to do that. There you go. And make sure we've got our arrows and we've labelled our axes. Alright, and put the equation of the graph, which is y equals half bracket 2x plus 4 all cubed minus 3. Alright, and that's pretty much everything.